Okay, you're good?
Yeah.
Okay. So the screen what you see, Susan, it is a virtual code editor where you can write your program and execute it. For example, you can set it as a Java and
Okay.
then click on this run code program. Once you are done with your programming, right, you can click on this run code program to see the output being printed on the console.
Okay.
That's the pattern of writing the code and executing it. Okay.
Okay.
And whatever the question I'm going to ask you, I'll make sure that I'll push the same question to your screen so that you can see what is being asked.
Okay.
Okay. And you can have a look that I have pushed one question to your screen under the problem statement section. You can see that.
Yeah.
If you want me to read out the problem statement, I can go ahead, or else, you know,
I'll read it.
you also can read.
Yeah.
I think you do not need to be loud. You can read on your own. If any clarification required, then let me know so that I can answer.
Okay. So basically, we are ingesting some transactional data, and we have to design and implement a data pipeline for this. And the main thing that we have to address is some idempotency, that we don't want to process the same data twice. And other than that, we also have to address that if there are some schema changes over time, then there should not be um, there should not be the ingestion should not be breaking based on some different schemas. So kind of a backward compatibility whenever we are doing some schema changes.
Mhm.
So first thing, like I will this how we are the pipeline, like design wise, what kind of pipeline is there, and failure, that I think that would be out of this scope of this question. So like if there are some breakage in pipeline and all, how will we replay it? So I think we will focus just on these two things here first. So for first, if I think about the idempotency thing, so one of the thing one of the solution would be, we can have a for every data that we have. um, so one thing is, we can have an idempotency key associated with every data. uh, we can generate it, or we can create it using some of the unique values that we are getting from the data itself. And if we and then we can have that, so whenever we are getting a new data, we can check using that key if this data has been processed earlier or not. And if it has been processed, we will just drop that entry and proceed forward. That could be one way to ensure idempotency in our input. um, so for this, we few solutions are there. Like if we need some kind of fast, very fast, like very low latency ingestions, then we can have this into this idempotency mapping in some cache as well. Or maybe this generally would be a pipeline only, so we can have some Flink kind of system, some system where we can just, whenever we are getting, it's very easy to query if this entry we have had earlier, or if latency is not that much of a requirement, this could be a simple DB call as well. We can just call a DB to check if we have seen this entry before. So that could be the way to solve for the idempotency thing. Now, other than this, for handling the schema changes, so basically here, um, few things we can do. Basically, one solution would be like the DB itself does not have, where we are storing this or ingesting this, does not have very strong, it's schema less basically. It does not have very strong, it does not break when schema changes. But considering this is kind of like transactional data, I think we need to have those, that solution would not be very optimal. We would need to have some kind of solution that makes that's compatible. Hmm. We can have some versions of schemas, and when we are ingesting data, maybe a query param could be the version of the schema that we are on. Like if I have a transaction object and I have some transaction ID and things like that, I can just have, and when I'm ingesting, sending that data through, I some query parametry can be a version of schema which I can. This generally is being maintained because we will have to have some schema maintained somewhere. Na first input that will be there. So this kind of is some config only that maintained, and we can just have some iterative versioning on this schema, and it could be the input parameter to like a query param to the uh, ingest API itself. And when then we are assuming it, we can do this using that version itself to get from our config. We will just get what the schema was. It has some downsides that there will be multiple, like if just one field has changed, we will be still storing uh, the entire schema again. So that would be one downside of it. Um,
Okay. Now, how are you going to avoid the full data reload? Hey, Srijan, like, is it okay? You can manage your light because it is focusing on the
yeah.
camera.
Sorry, sorry. 1 second.
Yeah, yeah, please go ahead. Thank you. This looks better, or else it is focusing on me.
Yeah.
Okay. How are you going to avoid the full data reload
Um, full data. I'm not sure what I like this or like
when you are having a schema drift, right?
right,
So over the time, so it has been clearly said that there should not be a schema drift. And you are making a change on the schema. Do you think that you have to reload whole data into a new schema?
right.
How do you want to take care of that?
So we have to have. I think that one solution is like the database solution that we are using. If that itself provides capability of changing schema where we are storing the data,
Mhm.
that would be one way to solve it. So some kind of, even I think most database have some settings, some configurations that you want some to change schema, but maybe very strong SQL consistency DBs will not have that capability. So in that case, think in basically, I'm thinking that when so when we are storing it.
Okay, let me ask in this way.
Okay.
Do you know what is a schema drift and how do you handle that?
Schema drift basically means if I have said like these four entries will be there in the event that I'm giving you, some entries maybe have changed their type or some new entries have added or got removed.
Mhm.
So
Is
that
that it? Is that you call that as a schema drift?
um, that is what
How
I have.
will you how will you handle that?
Yeah, that for that is I was saying ki I will have some kind of versioning of schema in the API itself. Like some version I will have. If someone has updated the schema, they will update their version, and in the ingest server, we will have some schema because we will have to have some config of what are we expecting, so we can have versions on that.
Mhm.
That could be one way to solve for it. For data reloads, basically we have to have a solution so that um,
Mhm. Okay. Okay. Makes sense. Okay. Let's go to the other topic. Your operation team needs some automated system that detect anomalies in logs and generate alerts or reports for engineers. The solution, which you are going to think, should analyze those logs continuously while detecting the abnormal patterns and also try to provide the dashboards for an operational visibility. How would you implement the automated log monitoring here?
right. Hmm. So basically, the some kind of basically we'll have some kind of continuous stream of data. So we'll have some logs, and there will be a continuous stream, and we have probably we can assume some kind of queue mechanism that will be bringing in that data, and on that we have to do some kind of computations. So the detecting, first I will just address the alerts part. So that part will be, so let's say some service I will have, the service that I'm making, let's say an anomaly detection service. So this is the easier part. I'm addressing that first. So what we will do is, in that service we can have certain rules. So for example, like in the last, whenever in last 5 minutes 5xx go more than 2%, so that service will have this in their configs, and some rules we will configure, and that service will have some kind of mechanism in which it will be processing that data. That mechanism we can abstract for now, but it has an ability that on the streams, that whatever data is coming, it is evaluating it every whatever window has been set up by the users, and evaluating for the rules that are there. So some rules we can configure, for example f5xx more than some percentage, and whenever it sees that rule, some we can trigger some action, whatever API action, a Slack message or a call or whatever. Now the main problem here would be how we process the data. That will be probably, this will be a very huge volume. So since these are logs and some metrics that are being emitted by services, so the write volume would be very long. So one question I would ask here is, do we also have to solve for these data coming and storing in DB, or we can just assume this data has been stored somewhere and this a stream is coming to us?
No, no. You have to design end to end.
Okay,
You have only the application logs.
right. So for that, first of all, we have to store these this the logs or whatever. Let's assume logs only. I think logs is only what is given here. Yeah. So first of all, from application server, we'll be getting logs. So first of all, we have to have a DB with, have to solve for a high write throughput. So because the writes here will be huge, and then reads will not be, like probably 1,000 to 1 ratio would be there from writes to read. So we have to choose a database which provides a very high write throughput for this. So for this we can use I think Cassandra or some time series database is also a very good solution here. So maybe like OpenTSDB, because they have in memory write. So they use some LSM tree architectures, which just writes in memory, and when a certain size has been reached, it flushes it to disk, and some SS tables are created and things like that. So it has a very high write throughput, but it is at the cost of reads, because now when we have to read, first we have to check memory, then disk, and in disk also there are multiple tables, we have to go through each of them. So there is a cost of read which we can optimize if we see reads not uh, to what we want, like not to what our requirement. But I think we have to first consider the write throughput. So my solution would be a Cassandra or OpenTSDB, for which we are just first storing the logs that are coming. So we can have some event ID which could be based off timestamp or things like that. And this is basically kind of de-normalize it. We don't have to have very strong normalization or SQL for things, because these are just logs which we will process later. So in Cassandra, we are just storing the logs with some log ID, and logs are being stored. On this, we can have, so most of the DBs like Cassandra as well provides this capability. Like whenever an entry is there, we have on a row, we can do a change data capture. So basically, whenever an entry is there, we can propagate that change to a particular queue or whatever we want to do. So we can particular something in AWS, we can do this as well through an SNS or SQS. So whenever a log comes, we put it into a streaming queue. So here, I think the best thing we can do is, um, since it is a very high write throughput, generally Kafka is a good solution, but I think in this case, some in-memory queue would be better, some RMQ as well. So I have like the scheduler that I talked about in my service, we use RMQ only because we also have a very high write throughput. So for those cases, RMQ is a very good solution. And the concerns which generally we have of, like persistence, that if RMQ goes down, we will lose. So those some lazy queue and other mechanisms are there in RMQ which can be used to solve that. So what we will do is in RMQ, we will push these logs, and there will be a stream of logs that will be coming once they enter into the database. And then we will have some kind of service that will process these logs. Now for this, like we can do implement our
Which service it will process the logs?
yeah, I'm coming to that. So I'm thinking, so we can implement our own service as well, but there are solutions for these kind of things. Like we have Spark, like batch processing can that Spark can do very well.
So
But
you want to? I want this to be runtime. There is
okay,
no batch.
okay. So in runtime, Flink is a very good solution here. So Flink is basically it will do in real time only. We partition it with maybe some service and all. So Flink will just read the solution, and it's actually very easy to implement as well. So there are few concepts. It has an input stream, it has an output stream. We can key some on basis of some, like whatever, some log ID, maybe service ID. So whatever the rule that I earlier said, na, some rule user will configure. So that service ID, we can from incoming logs, we will be on the basis of service ID, we will be getting the logs. And here we have a lot of ways in which, so Flink basically is also very fault tolerant. We also have a watermark concept in Flink, which is so if I'm defining like last 5 minute window, we have to analyze. So but it could be that the event was generated from the database, or the log was generated at 5, but it reached our Flink load at 5.3 or maybe 5.4 due to some network issue, some server restart or things like that. To handle this, Flink has a watermark kind of thing which we can configure. So it will say till like uh, whatever this 5 minute window is there, you can assume some buffer we will give. So maybe like 3 minutes earlier truck, it will wait and it will not process. So till 5.8 it will wait for those 5 minutes and it will process like that. And then we can, whatever the rules we have that was configured in the service itself, which was like for this service, if 5xx is gone, so that kind of filtering we can have in a Flink load for this service. If 5xx or whatever this rule is there in last 5 minutes, emit an event, and this event could be a call to a service, but ideally it should also be a queue only. And so generally the queue from Flink, we want it to be Kafka kind of thing, because there is a concept in Flink, if it goes down, if we want replayability, in that case, Kafka is a good solution. But I think because these are logs, these are not very, it's not that bad if we lose maybe 10, 20 logs in between. We will not, it's not the end of the world. It's not very mission critical data if you lose 20 logs in a stream of 100,000 logs. So I'm thinking for uniformity, we can have RMQ, a Flink load which processes this, and then RMQ which will have which will then we produce these alerts, which will and send these API calls. So that could be one of the solutions.
Okay. And for monitoring, what is that you will use it?
So for monitoring, so if we have these alerts, and if we so now what we want for monitoring, we want some dashboards, we want some metrics that can be so Grafana is a good tool here. We can emit these alerts metrics to Grafana, and we can have some dashboards and plots there as well, because we don't want to build everything from bottom up. This is a good technology, so we can use Grafana here for that.
Okay. 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 Makes sense. So let's move on to some database optimization. We can go through that question.
Yeah. That's a system. Well, no, slow. Right. So yeah, so this is a very common problem that every service faces. So there are two. So basically, if you are facing problems related to scale, first thing we have to identify before doing anything is what is the bottleneck, actually the bottleneck. So are the reads the bottleneck or the writes? Also, we have to first analyze what is the behavior query pattern of our service. If we have equal number of reads and write, we have more reads than writes, we have more writes than read. Because what that based on all of these answers, the solution would differ a lot. So that we have to identify first. So I think the interesting thing will be if we say for the case we have more writes, and for then one case if we have more reads. So we have some database whatever we have, then we, let's say we have a lot more writes than reads, and we are seeing a bottleneck that number of like the number of writes our database is not being able to handle. So first thing first, from simple we should start is if we can get a bigger machine. So I think most of people don't, which sounds very simple, it's not that interesting a solution, but that should also always be a first consideration. If we can just increase the size on a single machine or single database, because right, these days database have become a lot more powerful, a lot more storage. But yeah, keeping aside that, let's say if with a bigger database also we are not able to solve this problem, then we have to somehow partition our databases. So the data that we were earlier storing in one database, now maybe we are storing on 5 DBs. So for example, if we have let's say if, let's say transaction, we have a user transaction table, so which stores a transaction for user. Now a very important point here is to understand on what kind of key we would partition our data. So what that means is if we have a user transaction data, we want our partition key to be user ID, because if we don't have the partition key to be user ID, then a very common query here would be to get all the transactions for a particular user. Then when we are doing the reads, the transaction for a one user would be in very different database shards, maybe in partition shard 1, shard 3. So the read query itself will take a lot of it, and the reads will be very bad. So the query pattern should define what kind of partition key we are using. So generally that is the, like, whatever the read patterns are there, and also writes as well. So whenever it's very like a user will, the transaction mostly will be involving uh, one particular ID. So we want the reads and writes should always go to one particular shard. Obviously, it's not always possible to do this, but we should do this as much as possible. So we have to have a uh, basically shards for this, multiple shards. We can shard our data. Other than this, we can also have, if we have kind of, let's say, bursty traffic. So I'm just solving for if we have more writes. So if it could be, this is also a problem. This I also have faced before, that there is a very sudden burst of traffic during some peak hours or whatever, and suddenly our database got choked. It was very, very well during normal time, but suddenly a bursty traffic came. So for this, generally a good solution is to have some kind of queue in between our service and database, so that can queue can, kind of act as a sponge. It can, hand, it will be empty if there is not that much traffic, but if sudden burst of traffic is there, it will have a, it will just, the entries will be in queue itself. Of course, this adds some write latency to our write path, but this depends on the use case. If we don't want any writes to, fail whatsoever, but we can take some latency, so that would be a good solution here. um, Other than that, what else we can do for write? So some batching also is a one. So when, um, some batch writes we can do, so some db level optimizations are also there that we can do. So if there are certain traffic, we can also batch the writes together and send it to the db. So now for reads, let's say we have a problem with reads. Again, here one, obviously the, to see if, uh, so here one thing that we can do is replicate the data. So when we are having problem with reads, so let's say we are reading from one particular instance, we can just replicate it to maybe 4 instance and then read from all of those instances. Because, but this depends on what kind of consistency we want in our system. So if this is a replicated system, there are various ways to implement it. Every db, these are just configuration we have to provide, like it's a single leader one or multiple leaders. So if it's a single leader, then write will go to only 1 db and then it will be replicated to everyone. So we can read it from everywhere, but writes will only go to 1 db. But there are problems here of consistency. It could be that the write went to 1 db, but this db has not received the replication till now. And so there could be a stale read here, which is maybe we read from a follower which is not caught up for, which is not caught up for the data. So that would be a web, but there are ways to address this as well if you want very strong consistency. So for example, there's a transaction data. So in those kind of scenarios, we want very strong consistency. We cannot have stale reads. Someone sees stale bank account balance, so that is not desirable. So in that case, we have ways to in which we can solve for this. So we can have some kind of zookeeper instance, use some consensus algorithm we can use, so that our reads are linearizable, like everyone will agree. We can go into details how zookeeper does that if that is required, but that would be one way to solve for the consistency thing. One more thing for reads is we can have some cache as well, and that cache can significantly improve our read speeds. And we can have maybe a, a read through cache. So first we will check in cache. If it is not there, then we will go to db and populate the cache. Here also consistency can be a problem. If we want that, there could be an issue that, basically we went to cache, uh, no, we read a stale value in cache. So very, actually this problem I faced before. Actually we went to cache, we, the value was not there. We updated in the db, and then the another person who read, basic no, the write went to a leader and it updated it. The read went, it was not there in the cache, it read from a replica which was not up to the date, and then it will populate an older value in the cache. And since value would be there in the cache, everyone will think cache is okay only, and it will, just be reading some wrong value which is not there. So for these also we have to solve. So for this, some versioning, some kind of, with every db entry we have to have a version. So like even if someone updates, we will see like this db entry is, let's say, 42, we updated it to 43. So if someone even reads 42 value, it will update 42 value in cache. We are not no longer reading 42, we are now reading 43. So that way we can solve for this consistency issues. So these are some of the solutions that we can do. We can go into detail if anything is required.
Okay. Makes sense. Let's go to some Java 11. Let's see, like, you can have a look in the problem statement. Yeah.
Service and engage with multiple guys on slowly or occasionally fail. On handle timeouts properly and when non blocking. Design its integration using Java 11 HTTP client. Asynchronous calls handle timeouts properly. Non-blocking. The service can scale under load. Could you design this integration using Java? Okay. So in the HTTP client itself, there are so for timeouts
Can
and
you can you write the code for this?
okay. Uh, so a um, the exact syntax actually I'm not remembering right now. Um, it's not builder. Maybe some imports also would be needed. And this does not suggest imports actually. It could be import across.
It is not in a code intelligence. It is not going to give it.
Not intelligence like an ID gives, if you write, it will
Yeah,
give suggest the
code
import.
suggestions. It won't give it.
Yeah, so the exact syntax I'm not remembering. Some import also would be needed. I think then only I can do. But
Okay, you can share your screen and refer to the Java doc if you want.
okay. Uh, yeah, I've shared my screen. And I was typing this only, but it does not recognize it. So it is in Java Net HTTP. Is not getting it. Mm, not sure if it got it, but I've done load star only here. It's not getting. No, it's not working. Yeah. So basically, this HTTP client will have, so for timeouts, we can have some kind of timeout set for every API call. It is one of the input parameter for the HTTP client whenever we are making an API call. Other than this, some kind of, so what else is the requirement here? Let me just go to the external file server and response for you occasionally fail. So, respond is on blocking, so the servers can scale under. So we will have to, so since some external services there which can have some timeouts that are not under our control, so we'll have to some timeouts, like 20 seconds, 30 seconds, because after that we have to close the connection
No,
so
but
that
like,
service.
are you able to write the code?
Yeah, code is, so like timeout is, uh, we can give time unit.
What if it is not Java 11? What if anything else will you be able to write? At least you know. Can you write in any other Java JDK version?
Like, no, I use Java only. It's fine. The thing is, it is very, I don't know
I
if it
think
is
I have already given you access of this documentation. Still
okay.
you struggle?
No, I can write. It's not that. I'll write it. No. I'm not sure if it is. I'll just try and run the thing. So basically, some version we can have. Amount. Um, Other than this, we can have the external population. Another second. Check over now. Hmm, some headers version. This one. Some client dot send request. Yes, we can. So here, let's say if I give 30 seconds, this will be a map of headers. So if I have some uh, headers, uh, so we'll have a header map and just add some headers. Uh,
Got you. That's okay.
yeah, and here we will have the URL
Let's
we have to make first.
understood.
Yeah.
Let's get into some other topic. You understand saga design pattern?
Uh, yeah, I do.
Just see that how you can apply the saga pattern over here.
Just I'll just confirm once. Saga is basically if we have a basically if we want to make a distributed transaction. So if we took deducted money from one account, but we did not were not able to give the money to the other account, so we will just add the money back in this account, something like that.
Okay. So
This is what my
that is
understanding.
an example. I
Okay.
I don't need an example on a simple English.
No, I'm just confirming if that is correct. Otherwise, if I'm remembering some wrong thing only, we'll just go through the question once.
Yeah.
Okay. Services like order payment and inventory is no distributed transaction on constant feature coming. So we need to implement this, or what I'm thinking, how we can I can do this is at every level. If whenever we are doing doing performing any change, we will, if the later, like if some change we have done and the later change, we can just monitor it if there is some exception or whatever it fails. So with some recovery mechanism will be there for every change. So for example, if we have uh, an inventory class, so there would be a function to take some item, pick item, some quantity. With that, we'll have a recovery function as well to add item back with some quantity. Or if there is some money thing, we are deducting money or whatever. Order, we are reserving seat. Let's say we are doing a book my show kind of thing, we are reserving some seats. So with every function there would be a recovery functions to unreserved seat, to things like that. So whenever we are doing some change, then we will have, with every function for any kind of issues, first of all we'll have to have, there is not distributed transaction, but still we will have some logs for that particular thing. And when they we have, so that should be concurrent, first of thing. But if there is for the other thing, or whenever it fails, any exception due to whatever thing, we will do the recovery function for that, but whatever function we have done. So if do we need to, should I have to implement this?
No,
Okay.
but conceptually, I'm not agreeing what you have answered it. I'm like in a way that I get that answer on a theoretically, but only one thing is how it is being technically kind of implemented. That's what, see, in the Saga design pattern. There are some approaches to implement it. Do you know what are those approaches?
That exactly, I don't know. This I'm just from the question itself. I'm thinking. Actually, I'm not aware of the exact thing. So this is, I'm just thinking of on my own only how we can solve this problem if there is not a distributed transaction.
Have you ever worked on a distributed transaction by using Saga?
No.
Okay, okay. Then let's leave it if we are not sure, rather than guessing it on a simple English.
Okay.
Okay, let's proceed.
Okay.
See that if you can.
For an e-commerce platform, and frequently introduces new discount types such as seasonal offers. The solution must allow new discount types to be added, find existing code, and keep the design clean and maintainable as the platform grows. And next to the design. So we have uh, some kind of platform. It introduces new discount types such as seasonal offers, loyalty discount, promotional discount. The solution must allow new discount types to be added without modifying existing code, keep the design clean and maintainable as the platform goes. So here we can have kind of a factory pattern implementation. So some enums I would have of discount type. So I will have whatever, like the examples are there: seasonal, loyalty, and promotional. And I will have a factory class which will, rather than having multiple if else kind of thing in a thing, I will have a central factory class to which I will give. an enum, and it will provide me the discount object, and then we can do whatever thing. So the factory class would be simply whenever we are adding a new discount, so one enum we will have to add, and one function we will have to add in that factory class, and we'll be able to use it wherever we want to use in our code. So a factory pattern would solve this issue. Sorry, you are mute actually.
Factory pattern. How are you going to secure the API?
um I did not understand secure in what way.
Authentications.
Authentications.
Authentication and authorization. How are you going to secure your API?
So for that, one way is to basically we'll have to some tokens like the header from on header token we will have to have some roles or thing that we have to define. It depends if we have some kind of database for that, or we can using some like Google kind of thing also. So the whenever an API call comes, there is that the JWT token is there. So in that token some kind of roles and things are assigned. So one way is if we don't want very fine grained accesses, we can use that only. So for this particular account we can get from that token if this user is, and over that we can do. Main thing is it should be from the header only, the user ID or whatever is coming in the API body. We should never have any kind of authorization on that, because that is very easy to change, or someone in the request can be it's not that reliable. So from header only we will have to do. So then there are solutions. If we want very fine grained thing, then we can have our own Devi with some permissions and all. And because AWT token has very minimal things, then otherwise then we can create our own token and validate on that.
Got it. Hmm. Okay. Okay. Let's get back to the last topic. Let's see. You're leading a critical production deployment, and there is an unexpected issue. It happened after a release. You need to communicate that situation clearly to your non-technical stakeholders while managing their expectations and the next steps. How would you explain the issue and your action plan to your non-technical partner?
Right. So unfortunately, we have all faced these kind of things. So the main thing is whenever first of thing issue comes, we'll have to just stem it in the bud only. So whatever we have to stop the impact first, reduce the blast radius, whatever we have to roll back the deployment, thing like that. Now when it comes to communicating these things to non-technical people, so I think we will have to I should before that I think the first question there would be like the reasons on things like that. So an internal RCA I think we should do. And based on like what like basically good example, good template here is to ask like 5 whys. So why this issue occurred, when what the answer you get, whatever answer get, maybe because this feature that we introduced had a bug. Why this feature had a bug? Now for that we'll get maybe some if condition here, some threading issue here, some whatever issue here. So for that basically we will have to to get to the core of the thing. So when we are communicating it, because there from their side also some these questions would be there. Now also there we are before that I will also have some kind of uh, uh, some kind of things, some kind of solutions as to basically not get not getting these things. Sorry, think of some water. After getting, yeah, after doing some RCA, I will also like, so it will be I can just share the document also with very clearly and saying how why what caused this issue, but that will not be maybe that interesting to them. So there would be some solutions kind of thing that I will see analyze the issue myself also, if this is something that is could have been caught by us, or some kind of inherent structural changes we have to do in whatever monitoring and things like that, so that these kind of issues are caught before we even it has any impact or things like that.
I got it.
Also,
Okay. Yeah,
yeah,
I understood, Suzanne. Okay, that's all what I have it from my side. Do you have any questions for me?
yeah, okay, sure, got it. Okay,
Anything else?
I think it's fine. Yeah, it's good interview experience. Yeah,
Thank you so much. Nice talking to you. Have a
yeah,
nice day.
you too. Thank you.